So we're going to go over this problem, and the first place I'm going to start is I'm given two angles, right? I'm given the angle 14 pi over 6, and I'm given the angle 19 pi over 6. So the first place I'm going to start with is I'm going to actually find those two angles on the unit circle. So here's my unit circle. I'm going to first divide my unit circle in 4 parts. Okay, because those are degrees on angles in radians, and I'm not supposed to use a calculator, I don't want to go ahead and convert them to degrees. It won't be very difficult to do because I can simplify, but it's just a pain to do so. So I'm just instead going to count around the circle to find where they're located. So I notice right away that there's something like pi over 6. And I know that I have 3 special angles, pi over 6, I have pi over 4, and pi over 3. Those are my 3 special angles. Pi over 6 is equal to 30 degrees, pi over 4 is equal to 45 degrees, pi over 3 is equal to 60 degrees. So in this case, I'm dealing with pi over 6. Therefore, I'm going to start counting from 0, and I'm going to move. I have 14 times pi over 6. Okay, 14 times. Well, pi over 6 is 30 degrees. So what I really need is to separate my circle into 30 degrees. 30, here's 60, here's 90. So let's say this will be 30, this is going to be 60, this is going to be 90. Or I can also say this is pi over 6 one time, 2 times pi over 6, 3 times pi over 6, and as you notice, each 90 degrees I just gotta split in like 3 parts, right? All of those 90-degree angles, I gotta split them into 3 parts because 90-degree angles have 3 30-degree angles in them. 3 pi over 6, so I got 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6. You get where I'm going, right? We did this in class many times. 10 pi over 6, 11 pi over 6, 12 pi over 6, and now we have 13 pi again here, so this becomes sort of equivalent to 13 pi over 6, and this is kind of equivalent to 14 pi over 6. So the red angle that I have is actually over here. Okay, this is it. That's the reference angle. The whole angle is actually like 2 circles around one time, continues circling around and comes back here. Sorry, only one time. One time, one full time, right? And then a little bit of extra. But the reference angle is really the same as a 60-degree angle. So how do I find sine of this angle over here? How do I find sine of this angle? Well, sine will be the opposite side over the hypotenuse. Okay, opposite side over hypotenuse. I know this is 60. I know this is 30. I know this is 90. I know the hypotenuse in a unit circle is 1 unit. Therefore, I can right away find out that sine of 14 pi over 6 is really going to be equal to sine of 60 degrees. Well, we all did sine of 60 degrees, right? Remember, if the hypotenuse is 1, this will be 1/2. The opposite side is square root of 3 over 2. So I get square root of 3 over 2. Now let's find the other angle. The other angle is 19 pi over 6. So I reached 14 pi over 6. Here we have 15 pi over 6. Here we have 16 pi over 6. We've got 17 pi over 6, 18 pi over 6, and here we've got 19 pi over 6, right? 19 pi over 6. So I'm looking at this triangle, and the reference angle that I get is this one. And if I'm looking for sine of 19 pi over 6, I'm really looking, this is a 30-degree angle, right? I'm really looking for kind of this angle here. It's going to be a 30-degree angle, but with a minus in front of it. So I'm looking, because whatever I get down here is a negative, right? I'm looking for the opposite side. And this is the hypotenuse, which is equal to 1. So this will be equal to negative sine 30. Well, we know sine of 30 is 1/2, so this will be negative 1/2. So our sine of 14 pi over 6, is it equal to sine of 19 pi over 6? No, it's not equal. Now the second question relates to cosine. Well, we have to find, we know now sine of 19 pi over 6. However, what is cosine? Cosine is the adjacent side of the red angle. If we're looking for cosine of 14 pi over 6, we're looking for this adjacent side over here, for the length of it, right? So it's going to be equal to cosine of a 60-degree angle, which is equal to 1/2. Okay? Because if you notice, this red part is really equal to this blue part in length. However, this one's positive, and this one is going to be down here negative, right? It's negative because it goes in the negative direction. Therefore, the cosine angle is 1/2, and the other angle, the sine one, is negative 1/2. So therefore, I can conclude that cosine of 14 pi over 6, again, is not equal to 19 pi over 6. However, they're close, right? One is a negative, one's a positive. Okay, to get this problem done, you pretty much, I didn't use anything that I didn't teach you. You know how to put radians on a circle, how to put all those special angles on a circle. You know how to find a sine and a cosine. So bottom line, this question required you to use the knowledge that you've learned in different problems and just put it together. Okay, and that's when you really can call yourself highly proficient, when you're able to take those separate tools, you know, and those separate pieces of information, and you're able to combine them into solving a problem which looks different from what you've seen, but in reality doesn't require any new knowledge.